we're going to make trees today. That is prime factorization trees. Okay, so we're going to use prime factorization to kind of split up numbers into their components, into their prime factor components. Okay, so if you remember prime, what does that mean? Well, a prime number is just a number that only has factors that are 1 and itself, right? So that'd be 1, 2, 3, 5, 7, right? All those numbers that there's nothing else that goes into them except 1 in themselves. Okay, so what I'm going to do with 140 when I do prime factorization is I'm going to make a little tree, and I'm going to take out its smallest prime factor, which is 2. So then it has 70 left. I take out 2 again, I get 35. And if I take out a 5, then I'm going to get 7. So now I have all prime factors at the bottom, right? I can't split those up into anything else. So I'm just going to have 2 squared times 5 times 7. Those are the prime factors of 140. I'm going to do the same thing with 198. I take out the smallest prime factor, which is 2, and I have left 99. Then the smallest prime factor is 3, I get 33. Then I take out a 3 and I get 11. And I'm done there because I have all prime numbers at the bottom of the tree. Okay, I always like to circle my prime factors at the bottom. You guys have probably done this with Mrs. Grace back in 7th grade, and maybe more than that last year with Mr. Gandhi or with Mr. Bradley. Okay, so we're talking about the greatest common factor. Okay, so what is the greatest common factor? It's just the greatest number that goes into both numbers. So if we look at 8 and 6, 2 and 4 go into 8, and then 2 and 2. So then 6 splits up into 2 and 3, and I realize that the only number that these two have in common is 2. So the greatest common factor is 2. Let's say I take two other terms, 45 and 75. Okay, I'm going to take 3 out of 45, I'm left with 15. I take out 3 again, I'm left with 5. I'm done there. I take out 3 out of 75, I get 25, which splits up to 5 and 5. Okay, I notice that they each have a 3, and they each have at least one 5. Which means that the greatest common factor is 3 times 5, which is 15. Okay, so greatest common factor between 45 and 75 is 15. Okay, now we're going to talk about the least common multiple. Okay, so the least common multiple, suppose you're like counting by numbers. Okay, the first number that two different things have in common. Let's say 8 and 6. Let's say I'm counting by 6s. I get 6, 12, 18, 24. And then if I count by 8s, I get 8, 16, 24. The first number that they have in common is 24. So that's their least common multiple. Now let's see how we would do this with prime factorization. If I take 8, I split that up into 2 and 4, and then 2 and 2. And then 6 just splits up into 2 and 3. So I'm going to take the first factor that there exists in either of these numbers, and it's 2. Now 8 has the most 2's. It has 3 2's, so I'm going to do 2 cubed. And then I look at 6. It has a 3, okay, and it has the most 3's, right? 8 doesn't have any. So I just put that in, and I get 8 times 3, which is 24. Okay, we're going to do more examples with this so you can see how it works. So if I take 22x y squared, z squared, and then I get this term 33x squared yz squared, and then 44x squared yz. First, I'm going to find their greatest common factor. Okay, so I'm going to factor this into 2 and 11. The next one is 3 and 11. This is 4 and 11, which splits up into 2 and 2. Okay, so I've got the prime factorization going. So the greatest common factor is what they all have in common. And I notice that they all only have 11 in common. If you look, 33 doesn't have a 2, so the only thing that they have in common is that 11. And then they all have an x, they all have at least one y, and they all have at least one z. Okay, so you're taking, whoever has the least amount, right? They all have at least z, but they don't have more than one z. Okay, so then I'm going to look at the least common multiple. I have a factor of 2. The one that has the most 2's is 44. It has 2 2's, so I do 2 squared. Then I take 3. I realize that 33 has the most 3's. And then I take 11. They all have 1 11, so I just put 11. And then the maximum x is x squared, the maximum y is y squared, and the maximum z is z squared. Okay, so then if I multiply all that out, then I get 4 times 33, x squared, y squared, z squared, which is 132 x squared, y squared, z squared. So when I counted by all those numbers, I would get 132 x squared, y squared, z squared. Okay, let's do it again. Suppose I have new factors, or new numbers, 200, a cubed, b squared, c, 300, a squared, b, c squared. I actually think that should be c cubed. I'm going to change it in a second here. And then 400, a, b cubed, c squared. Okay, so first thing I got to do is prime factorize every single number. So in the first number, I'm going to take out 2. and I'm going to get 100, and then I take out 2, I get 50, 2 and 25, and then 5 and 5. Okay, I'm going to do the same thing with 300, right? 3 and 100, 2 and 50, 2 and 25, and then 5 and 5. Okay, same thing with 400. I'm just going to take out 4 and have 100 so that everything is going to look kind of the same. I circle those 2 2s that I split up 4 and 2, and then I got 2 and 25, and then 5 and 5. Okay, greatest common factor. So I can see that they all have 2 2s and 2 5s, right? And they have nothing else in common, so 2 2s and 2 5s would be 100. And they each have at least one A, at least one B, at least one C. Okay, so that's the greatest common factor. Least common multiple. The first factor that I see that exists is 2. Who has the most 2s? Well, 400 has 4 2s, so I do 2 to the 4th. The next factor is 3. I see that the only one who has 3 is 300. Okay, the next factor is 5. They all have 2 5s, so 5 squared. And then I have A cubed, B cubed, C cubed, right? Those are the maximum number of A's, B's, and C's that I have in any of the 3 terms. Okay, if I multiply all of that out, I'm going to get 4 times 4 times 3 times 25, which ends up as 1200 A cubed, B cubed, C cubed. Good luck on your homework and have a great day.